So we're going to go over rate laws that use zeroth order, and that's an expression where our rate is equal to some constant k times a to the 0, which becomes 1. So our rate constant is really the same as our rate. So it's independent of the amount that we have here. So this is the expression that we go there, and if we again do just a little bit of calculus, what we arrive at is a at some time t is equal to negative k times t plus a, the original amount. And if I were to plot that, concentration of A at whatever time t, I would get a downward sloping line that looks a bit like that, where the slope of that line is equal to our rate constant. So again, this is a y equals mx plus b slope-intercept form of a line. If I wanted to work out the half-life for this, which is the time at which our concentration at some time t is half of what we started with, then I can just plug in here, and I'll drop the brackets for right now just for ease of writing. It looks a little bit like this. I'll subtract a naught from both sides, so that'll become negative a naught over 2 is equal to negative kt, and I can get rid of the negatives on both sides, so a naught over 2 is equal to kt, and that will be our half-life. Okay, so this allows us to figure out pretty easily, if we know the rate constant, we can figure out the half-life, or if we know the half-life, we can figure out the rate constant as long as we know the initial concentration of A naught. Now, in this reaction, we're using a zeroth order rate constant of A going to B, and the constant K has this value, 0.355 molar per second. If the initial concentration is 0.5 molar, how long will it take until only 25% remains? That means 75% of it has gone away. So the new concentration will be 25% of this. So our concentration A at that time t is going to end up being 0.25 times 0.5, which is 0.125 molar. Okay? So what I'm going to do now is just plug that into this expression here. So 0.125 molar is equal to negative 0.355. But this time, instead of trying to get a concentration, I want T, and that's being added to my initial concentration, which is 0.55500 molar. So when I go through and plug this into my calculator, that is, subtract 0.5 from both sides, divide by negative 0.355, the time that I end up with is 1.06 seconds. This is something that happens really quite quickly. So not at all unheard of, but that's sort of how this ends up working. So hope that works for you for integrated rate laws, zeroth order.